Now let us study about discharging of capacitor. Now earlier we studied all about the charging of capacitor. Now we have a capacitor which is already charged and it has charges plus Q and minus Q on its plates, and this capacitor is connected to a switch. There is no voltage battery here because we are just discharging the capacitor and see how it goes. So if the switch is closed, then the electrons on this plate start traveling to the other side, and both plus Q and minus Q will neutralize each other very quickly. So all of a sudden at t equals to 0, when the switch is closed, then the charge, to neutralize the charge, there will be a current which will be generated in this circuit, and this current will flow. The current flow in the circuit will be very high and it will be very fast. So if we plot the graph of this discharging, just like we plotted graph of charging. Now if we plot the graph of discharging, then initially before t equals to 0, before the switch was closed, so before this the charge on the capacitor was Q, and after the switch is closed a sudden neutralization takes place and very quickly the charge becomes equal to 0. So this is also transient time. Just like we studied in previous videos during charging, this is the transient time of discharging. So as soon as the switch is closed, the charge becomes equal to 0, and this transient time is so small that we can assume that it is tending towards 0. Now if resistance is connected, now let us connect a resistance with this capacitor. A resistance is connected, and now if the switch is closed, then a current will start flowing, and then that current will be stopped or slowed down because of this resistance. So the process of discharging becomes slow. So now if we plot the graph, then before closing the switch, before t equals to 0, the charge will be equal to capital Q, and as soon as the resistance is connected, the process of discharging will be slow. So instead the charge coming down to 0 quickly, it will gradually come down to 0 in a curved way like this, and at some time t equal to infinity the capacitor will be completely discharged. Now this curve, the slope of this curve depends upon the value of R. If we have a resistance R dash which is greater than R, then the discharging will take even more time and the graph will come out to be like this. This will be the curve for R dash and this will be the curve for R. And if we have R dash less than R, then the discharging will take place quickly and the curve will be like this. So depending on the value of R, the time duration of discharging of capacitor can be controlled, and this is how capacitor is discharged across a circuit.